Am I audible? Jasleen Ibrahim?
Yes, ma'am.
Ibrahim, to you?
What, ma'am?
Okay, am I audible? I was just checking.
Yes, ma'am. Yes, ma'am.
Okay. See, in the last class, we discussed electric field due to a dipole. So these are the two special cases that we know, but we also discussed it for a general point. That was E is equal to Kp by R cube under root 1 plus 3 cos square theta. From here, you can, this is the general formula. From here, you can get the values of equatorial and axial also. Then tan theta also we saw that tan phi and tan theta also have a relation, that tan phi is equal to tan theta by 2. And we also saw the dipole moment, that was the net dipole moments formula was like the formula of the parallelogram, right? Now, when when we are talking about the dipole in external field, dipole in external electric field. So when the dipole is put in external electric field, we know the net force that acts on it is 0, the net force, but there's a quantity that acts, that is the torque. So torque will be P cross E, which can be written as PE sine theta. Okay, there is potential energy also that we'll discuss in the second chapter. After we complete, no, on Wednesday only we'll discuss it. We have completed that portion. Now potential energy we'll discuss. So I'm just writing it here so that your notes are complete, but the discussion part we'll do later. Potential energy is actually minus P dot E. So this is written as minus PE cos theta. Now the work of torque, we know the work of torque is to align the dipole parallel to electric field. That's the work of the torque. So in that we have three cases. Three cases are important here also. We have already done those. First is when you have the angle as 0 degree, right? Theta is 0 degree. So your torque, it becomes P E sine 0, that is 0. And this, when theta is 0, in the first case, it's a condition of stable equilibrium. This is also important in your statement-based questions. This has been asked. Stable equilibrium. Okay. Next is when theta is 180 degree. Theta 180 degree means what? Your dipole moment and your electric field, they are anti-parallel to each other. So that is what is meant by 180. So torque will be, see here also torque will be PE sine 180 degree, and this will be 0. But this is a case of unstable equilibrium. Then you have the third, that is theta is 90 degree. So torque will be PE sine 90 degree. Now you know sine 90 degree is 1, so this is equal to PE. Here we get the maximum value of the torque. Okay. Here we get the maximum value of torque. Here we get the maximum value of energy in these cases. Okay. The maximum value of energy. PE, in this case, your potential energy becomes 0. So I'm not emphasizing so much on potential energy because you need to study potential energy separately. But apart from this, you have some more things in torque that can come in your NEET exam. Torque is I alpha. Okay, from your class 11. Torque is equal to I alpha. Okay, this is a formula from your class 11, correct? So your alpha's value can be asked to you in your exam. What is the value of angular acceleration? Let me write it separately. You can be asked to calculate the angular acceleration of the dipole. if you are asked to calculate the acceleration of the dipole, and in case you forget the formula, try to recall this. Tau is IL. Now, what are the symbols? Tau, this is the torque. I, this is the moment of inertia. And alpha is the angular acceleration. See, this is not tough, but it's just that this has to be related with 11th class portion. Angular acceleration. So, formula of the alpha is P E sine theta divided by the moment of inertia. Okay, class, this can be asked to you. Alpha, what's the value of alpha? Okay. Now, if you know alpha's value is asked, then you must be already ready with the value of time period also. Like angular acceleration is asked, so you can be asked the value of the time period of rotation of dipole. Rotation of dipole. So this is the question which we discussed in the class, the SHM question. Simple harmonic question. Remember class 1 question we did where I told you that torque is equal to PE sine theta. The derivation is very simple. Torque is PE sine theta. Then we discussed that when the dipole is rotating, the angle is so less. So in small angle approximation or less angle, sine theta can be written approximately equal to theta. So tau can be written as PE theta. From here we get the value of K. Remember we did a question, yes or no? Are you able to recall this?
Yes, ma'am.
Yes, ma'am.
Okay. So the formula of the time period will be 2 pi under root I by PE. So we discussed this also as a question, but this has been asked separately. Not recently, but in your previous year's question, if you see, this has been asked. Okay. And regarding energy, I'll discuss again, but yes, there's one more point that the work done, which is, or it will be confusing. Energy, we'll do it separate. So this is important. And let's practice the numericals then. You have good questions from this topic to practice. And Ibrahim has done the previous assignment also. Well, all the questions were from your NEET previous years only, Ibrahim. Jesslyn, you also shared the homework. You must be busy with the exams. So whenever you get time, Jesslyn, please share your homework also. NEET homework is left because all the questions of Ibrahim were correct. Ibrahim, one more thing, steps. Just mention the steps. That's it. Your answers are correct. I want to see your steps. How are you getting your correct answer? Okay. Which method
Yes,
you are
ma'am.
applying? Okay, class.
Yes.
Noted from here. See class, this question says a dipole of dipole moment P and moment of inertia I. Moment of inertia I is released from rest, okay, in uniform electric field. So moment of inertia is given as I, the dipole moment is given as P, and the electric field is uniform electric field E. It says find angular speed when it passes through equilibrium. Okay, find the angular speed when it passes through equilibrium. This means that, see, when it is in equilibrium, what are the conditions that are possible? And for calculation of angular speed, see class, as soon as you have speed in your calculations, you have to relate it with kinetic energy. Okay, class, throughout your NEET problems, whatever questions you have in, whether it's NEET or JEE, whenever you get speed and you are unable to relate it with anything, like this is a question of electrostatics, dipole moment. From here, your class 11's rotational mechanics has been introduced, moment of inertia has been introduced, where your electric field is already present. So one thing, the way to solve this question is bring up your class 11's conservation of energy. That's the only method, because in your energy conservation, you have kinetic energy, right? And from kinetic energy class, you have the speed that is present, speed, which is angular speed or the linear speed. So you should use the conservation of energy. So conservation of energy, when the initial total energy is equal to the final total energy. Now, what is this total initial? Kinetic plus potential. So initial kinetic, initial potential is equal to final kinetic, final potential, right? So we are going to just apply the conservation of energy. That will do us fine. Now, it is saying through equilibrium. When it passes through equilibrium, we have seen in which conditions we got equilibrium. One was 0 degree, other one was 180 degree. It means we just have these two angles that are present. Theta is 0 degree or theta is equal to 180 degree when equilibrium can be achieved, right? So a random angle will be started from here. Let's say this is, let me draw the electric. Let's say this is the dipole. Here the dipole is present. Let's say the angle here is some theta initially. Now where will this dipole be present? This dipole will be present till here when the angle is finally 0 degree. Right? Yes. Now look, when we are talking about the initial energy, see what does it become? Initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. Okay. So what will be the initial kinetic energy class? When the dipole is at rest, it has not moved like this. The initial kinetic energy will be 0. Now potential energy we have not discussed in detail, but I told you the formula. So from potential energy, you can see that potential energy's formula is minus PE cos theta. Okay, this formula we'll discuss in our regular class, but class, your questions of electrostatics are mixed, especially from the torque part. Your work done in energy part is very much mixed. That's why I had to discuss this formula today. Then this is final kinetic energy. See, when it starts to move, when this starts to rotate. So here the angular velocity is omega. So this is half I omega square. And final will also be minus PE, but this will be minus PE cos 0 degree, right? Final potential energy will be minus PE cos 0 degree because angle is 0. Potential energies will be existing. Initially, it was at rest, so kinetic was 0. Final kinetic energy is half I omega square because it has started moving. Now we just have these things and we have to add it up. Cos 0 degree is 1, so that is minus PE. Here we have minus PE cos theta and half I omega square is present and initial kinetic energy is already 0 from here. So we need to get the omega. So this will be, see, we are going to shift it here. PE minus PE cos theta. This 2 will get multiplied and I will be divided. This much is equal to omega square class. Now look, PE minus PE cos theta. We can take PE outside. Look, omega will be 2PE. What is left in the bracket? 1 minus cos theta divided by I under root. So this is the complete answer to this. Okay, this is the complete answer to this. Wait. Okay, above part you have already written. The question one was left. Okay. So is this question clear to both of you? Ibrahim, Jasleen.
Yes, ma'am.
Okay, please write it. We'll see one more question.
Ma'am, can you scroll?
Look, class. This says two electric dipoles A and B. So they are given in the form of figure. Have their electric dipole moments as P1 and P2 respectively. Now this says they are placed on planes with their centers at O. So that is already given in the figure. It is saying at the point C that was present at the corner. I'll show you. On the axis of the dipole A, the resultant electric field is making an angle of 37 degree with the axis. So see again, your dipole's resultant angle is 37 degree. You need to calculate the ratio of the dipole moment of A and B, which is P1 by P2. So class, see, the language is very tough in this question. Calculation part is very easy. Once you will see, so you need to understand the language of the question. You've seen this year's NEET paper or not? In this year's NEET paper, the entire questions were filled with heavy languages where they needed to be decoded first. So concepts are very important apart from your extra questions, extra formula and everything. Whatever basic questions that are there already in your NCERT, if your concepts are fine, then you'll be able to attempt all the questions well. If you look at the paper, when you analyze the paper, there are few questions that were very tough, but apart from that, the questions were moderate. Okay, very few questions were there that were from your previous years also. Many questions came from your previous years as it is. So practice the assignments. They have all the previous years questions. In the class, we practice the conceptual questions and the previous years. In assignments, completely previous years questions are given. And try to attempt it by yourself. If you're not able to do any question, just leave it. See, this is your dipole A. This is dipole B. And this is the point C. So here, let's say the resultant is somewhere here. So this resultant is making an angle of 37 degree. This is the resultant. So it means there are two. This is the resultant. So how is it formed? It must have been, if this is the resultant, then it must have been formed with the help of these two vectors like this. Then only, no, its resultant is lying across the diagonal of the parallelogram. So let's say this is some P1, this is some P2. Let's say this is P1, this is P2. We are not even saying it. It is mentioned in the question that A1 is P1 and B is P2. This dipole is P1 and this dipole is B2. This is P2. This is given in the question. Now look, this, what is meant by this? The net dipole moment is at an angle of 37 degree. Class, you just have to identify. Can you tell me? Both of you just answer me in the chat box quickly. Is P1 or just forget P1, just look, is C point axial or at equatorial for A? This is your dipole A. From O, this is your P1. So tell me. Yeah. Axial. Very good. So this is axial. And for axial, you know, it is 2kp by r cube. So this will become 2kp1 by r cube. Correct? And can you tell me for P2, is this also axial? For B, is C point at equatorial or axial for this B? Answer in the chat box only. For the dipole B, is the point C on the axial or on the equatorial of it? Yes, Ibrahim is right. See, Jesslyn, look, this is the axis. This isn't lying on the axis. This is perpendicular to it. Look, 90 degree. So C is equatorial. So when this is equatorial, this will become Kp by r cube. So Kp2 by r cube. Now you need to take the ratio. And one thing, if you remember, I've already told you that this resultant's angle is your tan phi, which is given here as 37 degree. Right? So your question will become C. This is tan 37 degree given. Remember in the theory part of the last class, we discussed this. So tan 37 degree will be your P1 by P2. This will be P1 by P2. So K, no, it will be opposite. Perpendicular is P2, no? So P2 will come above. Tan is like this, no? So tan P2 by P1. So P2 is Kp by RQ, P2 by RQ. This is 2 Kp1 by RQ, right? And it has also said that take how much? 3 by 5. Take sine 37, it is saying. Okay, forget. We have our tan value. Okay, so tan 37 is 3 by 4. So this becomes 3 by 4 because sine 37 is not needed. Sine 37 is given that through the help of sine 37, you can calculate tan 37 or cos 37. That's why it is given. So your tan 37 is 3 by 4. So we are going to use this. Sine 37 is 3 by 5. How do you calculate this? What I am saying? How do I know that this is 3 by 4? I did not remember it. I just calculated it right now. How? See, when it says sine 37, sine 37 is 3 by 5. Now you know what is your sine theta? Perpendicular upon hypotenuse. So it is saying sine 37 is 3 by 5. Means 3 by 5 is P by H. Means perpendicular is some 3 units. The hypotenuse is 5 units. They are making the part that is missing is from your Pythagorean triplet. So your base will be 4 units. And what is tan theta? Tan theta is perpendicular by base. So from here I have got this 3 by 4. That's how I know that tan 37 will be 3 by 4. Just because sine 37 was given, tan 37 or cos 37 can also be calculated. So tan 37 is 3 by 4. See k, r cube will be cancelled. This will be P2 by 2, P1. We need the ratio of P1 by P2. So it will be, this becomes 2. So 2 by 3. 2 by 3 is the answer. Which option class is matching? D. Is this question clear to both of you, Jasleen Ibrahim?
Yes, ma'am.
Yes, ma'am.
Properly, without any doubts, with the full concepts?
Yes, ma'am.
Okay. If you have to ask anything in between, please ask me. Write down this question. This was a good question, a very good question, which involves most of your concept. Class done?
Yes.
Jesslyn, what about you? Done?
Yes, ma'am.
Okay. So, class, now dipole